Hello and welcome to another power session with Mama L. We're doing volume part 2, changing the dimensions today. Now I did a volume part 1 where we were learning the basics of how we find the volume of our different shapes, our three-dimensional figures. And today we're going to learn how changing the dimensions of the shape affects the volume. So we might change the height or the width or the length or something like that and see how it affects the volume. Okay. So I want to quickly remind you of my pancake theory. Imagine that you have this 3D shape, okay, this shape that has depth to it and you could fill space with it. Okay. Well, the idea is that if you have a flat pancake, any flat shape, you can take that shape and then multiply it by a height of the stack of pancakes. So if I have a flat circle or a flat square, if I multiply that by how many pancakes are in my stack, that's going to give me a prism. And then if I have a pyramid or cone and I'm taking that shape and I'm kind of shaving off some things, I have to share 2/3 of that with my siblings, right? So I only get 1/3 of it. So what happens is you divide by 3, and that's going to be the formula for that shape. So if I had a square pyramid, for example, I would have square pancakes multiplied by the height going up to the very top, and then I would divide by 3 so that I can get the final volume of that shape. Alright, so if I eat half my stack of pancakes, what would the new volume of my stack be? Okay, so you've got this original stack over here on the right, and if I were to cut that in half right here, well, suddenly I just changed a dimension, right? I just chopped my height in half, and that's changing the outcome of what my volume is going to be. So let's try some problems together. And we have to carefully look at how they do these sorts of problems. They're gonna keep you on your toes because they want you to pay attention to all the little details, okay? This one says the smaller rectangular prism has an equal height and length. Okay, so height and length are the same number. We don't know what that number is, but it helps to know that they're equal. And I'll put over here H equals L. And the width is 2 times the length. So now the width, W, is 2 times the length. If I say that just like I hear that, width is 2 lengths, I could put W equals 2 L's. So now all of a sudden we have everything in terms of L's. The height is equal to the length, so I'm going to change that to L. And the width is equal to 2 lengths. So that really helps me out. Remember, anytime you can get a problem down to one variable, that's really going to make your life much easier. Okay, so it says if the volume of the smaller box is 16 inches cubed, what is the volume of the larger box? Well, let's quickly take a look here at how to get the volume of the smaller box, okay? But you're multiplying its 3 dimensions. Okay, again, if you want to imagine the pancakes, you can imagine that bottom rectangular pancake stacked up, or you could imagine that front square pancake stretched out to the back, either way. But we're getting L times 2L because we said H was L. L is obviously equal to L, and width was equal to 2 L's. So when we multiply those to get our volume, we end up with 16 inches cubed. Okay, well, look at what we can do. We can actually combine our L's, get our L's together, L times L times L, and I'll put those off to the side. But they're also being multiplied by 2. So let's go ahead now and just divide that 2 away to get our L's all alone. And we know that a number cubed, or a number times itself 3 times, will equal 8. What number times itself equals 8? Well, 2, right? 2 times 2 times 2. So L, or the length, is 2. Now I'm going to take that piece of information just like a detective would and put it in the information I need for the larger box, okay? Now it said H was L, so I get to go ahead and say that's L. Now all of a sudden my length is twice that amount, and then my width is also still 2L. Okay, so I can say, all right, I'm going to change things up just slightly because they changed one dimension. All right, so again, height times length times width. We know that height was equal to length. Now they made length a little bit longer, twice as long, and then the width was also 2 lengths. Okay, well, I know because I just solved it from my earlier box that L is 2. So 2, and I'll put 2, and I'll put 2 for all my lengths there. Can't forget these other 2's though. Okay, so I'm actually doing 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So if I do all that multiplication, I'm going to get 32 inches cubed. Again, three-dimensional, has a little 3 in my label. All right, let's go ahead and give this one a try now. If the volume of the larger sphere is 72 pi centimeters cubed, remember that 72 pi is the amount of the volume. Centimeters cubed, that's just going to be your label, okay? So the larger one has a radius that's twice the smaller one. So let's look at the formula for the volume of a sphere, okay? 4/3 pi times radius cubed. Remember, that's radius times radius times radius, okay? I'm going to write it on the right as well. All right, so let's see what happens if we have 4/3 pi r cubed, and we're comparing that, oops, I need to put cubed over here, excuse me. If we're comparing that to this one, there's only one radius. Let's see what happens when the thing that changes is getting cubed, okay? So instead of plain r, we're doing 2r times 2r times 2r. So we've got our 4/3 and our pi, but now we have 2r times 2r times 2r. Okay, just to look at the difference between 4/3 pi r times r times r. So now you're going to go ahead, and if you were to cube the two r's, everything would look exactly the same between these two formulas, except we have extra 2's we're multiplying by. 2 times 2 times 2. So that means the difference between these two formulas is this volume is going to be 8 times as big. 2 times 2 is 4, times 2 is 8. So the volume of this bigger sphere is 8 times as big. We just doubled the radius, but look at how much more volume we got when we did that. Okay, so if we know that that volume is going to be 8 times as big as the small one, well, 72 is our volume. They tell us that in the problem. That's 8 times as big as the small one. So what number times 8 is going to be 72? 9. Okay, so on that one, we know that the volume of the smaller sphere is going to be 9 pi centimeters cubed. Let's try another one. If the volume of the smaller box is 27 inches cubed, then what's the volume of the larger box? All right, they're not going to give us any fancy directions here, but they've shown us by looking at the picture that we've doubled all the dimensions, right? So remember, the smaller box is going to be the 3 dimensions multiplied. Height times length times width. And then the larger one is going to be 2 height times 2 length times 2 width, if everything was doubled. Okay? Well, 27 is the result of when you multiply those 3 dimensions. Okay? And look what happens. What number times itself, because this is a cube, what number times itself is 27? Well, 3 times 3 times 3. There is your 27. So we know that these are all 3. So if we're going to double that, 2 times 3 is going to be 6. 2 times 3 is going to be 6, and 2 times 3 is going to be 6. So there are our new dimensions. If we go ahead and cube those, 6 times 6 is 36, and 36 times 6 is 216. All right, and that's inches cubed. And that's the final answer. Thanks for watching. I hope this helped you refine your skills on what happens when you change the dimensions of a 3D shape. Hope you can watch my sessions on surface area as well, because that's going to help too. Thanks. Have a good day.